Hello guys, my name is Arina Paul and today I'll be talking about the Dualit full slice toaster and I will be providing a device functional analysis for the same. So starting off on why I decided to select the Dualit two slice pop-up toaster is because even though it performs a very simple task, that is, it toasts a bread, it is actually performing a complex task. Even though the process may appear very simple, it is not. The complex task which is performed here is that it converts electrical energy from the circuit, which is the plug point when we turn on the switch, which is produced from the circuit to heat. So once this electrical energy is converted to heat, this heat will be used to warm the bread and to make it toast. And simultaneously, it will be cutting the power after a set time. So this involves a combination of many systems, which are majorly electrical, mechanical, and thermodynamic systems. The next thing I'm going to talk about is the tear down process. So this is I have shown here is an image of the Dualit Blue Slice pop-up toaster, and there's you can virtually observe it, and there are a lot of labeling such as how wide are the wide slots are there, and this is 36 wide to fit in the bread buns and sandwich cases. And this is a crumb tray which will catch the breadcrumbs and keep your work surface clean. And this is the cable tidy. It is used to keep the surface clear. There are extra buttons here. This is the defrost button, which is used to toast frozen bread. And this is the bagel button, which is used to toast. So one side will be toasted and the other side is gently warmed. This is a switch for that. And here we have our browning control switch, which is used to set the desired toasting level. You can set it by rotating it, and there's even a cancel button. Here we see is the toasting lever. This toasting lever, after the breadcrumb is placed, is pulled down. And the switch is on, and you can see the power neon, which will illuminate. It will show that the toaster is working. It will illuminate a neon light. The tear down process. So the screws hold. So first is when we remove the casing, we will see that the screw holding the plastic or metallic exterior is first removed. And then we have to identify the mechanics. So the mechanics which is mainly involved is the spring and the internal metal basket. The internal metal basket here is the one in which the bread is placed, and the spring is the one with which the help of the lever is pulled down. The electric path which is followed here is first it traces from the power cord to the control circuit board, the timer and the heating elements. So first we on this switch, and then this will be traced back to the timer and the heating element. The heating element mainly involved in the Dualit two-slice toaster is the nichrome wires. So nichrome wires will be running along the interior walls of the bread slots. So that is our major teardown process. Next we have is a so next we come to the functional blocks. So in the functional blocks we have five major primary functional blocks, which include the power input, carriage mechanism, latch and heating elements, and lastly control and timers. So in the power input, 120 volts or 240 volts of household electricity is taken from the power outlet, and the power is protected by a fuse is directed throughout the system. So a fuse obviously will be used to prevent the user from getting electrical shocks or circuit problems, and the power after being taken from the power outlet will be directed throughout the system. Next, we are talking about the carriage mechanism. Here, in case of the carriage, we are basically talking about the bread casket. So, the mechanical system is operated by the external lever. So, it moves the bread casket down into the heating chamber. This motion will compress the spring and catch the latch. So basically, after placing the bread into the casket or the carriage, the lever will be pulled down, and this motion will basically compress the spring and it will catch the latch. This is the way each system is operating with each other to keep the bread in place. This is the carriage mechanism. Now, when we're talking about the latch, in usually electric toasters, this latch will be electromagnetic latch. So in ours, in general, on pressing the lever, the gasket will be held under the latch. But in case of electric toaster, there will be an electromagnet that will remain active as long as the main heating circuit is powered. Once the powering is cut off, the latch is let go off and the bread will be ejected out. Next, we come to the heating element. The nichrome wires are the major heating element. Nichrome is basically a nickel and chromium alloy. They are the main heating element, and when electricity is passed through them, they heat up because they have high electric resistance and they radiate infrared energy, which will help in toasting the bread. The last component is the control and timer. This is a very crucial block which will determine when to stop the toasting process. It consists of a very precise electronic timer RC circuit or a robust manual wind-up mechanical timer. It keeps a check on the set duration and the heat. Once the set time is reached, the block will cut the power to the latch or the electromagnet. And this is how the toasting process will be stopped and the bread is ejected out. Next, I'll be talking about the different domains which are involved in our Dualit two-slice pop-up toaster. So the main domains are electrical, mechanical, and thermal materials. So the electrical components in our model is the power cord, the nichrome wires, electronic, mechanical, timer circuit. So they provide energy and accurate time control signals which will be required for the operation, that is heating the bread. Next, the mechanical components involve lever, carriage, which is the bread basket, spring, a thumb tray, latch pivot points. So these provide movement, structure, and stability to hold the bread in place and later eject the bread out when the time is up. The material and thermal science part of this is the nichrome, which is our major heating element. So nichrome converts the electrical energy into thermal energy and provides the energy to the process is this particular domain. But we have to note that this domain is decoupled from the timing control. The key linkage is how the mechanical latch will be held by the electromagnet and how the electrical power to that magnet will be controlled by the electronic and mechanical timer circuit. The main insight which I have got through this project is first, the implementation of a robust and accurate electronic timer or mechanical timer is quite surprising. Dualit measures a set time instead of depending on the heat feedback as the system is decoupled from the main heating circuit, which also eliminates certain problems like variable toasting time. The mechanical action of pushing the lever down acts as a safety measure. When the power is cut to the latch by the timer, the spring is released, causing the bread to get ejected. This simultaneously cuts power to the heating elements. Therefore, the new design relies on time management and robust components, unlike the old ones, making it more durable and consistent. Thank you.